Hello, my name is Frank Plowman and this is my demonstration video for my ELEC3662 project. Here is the calculator. You can see the external interface of the device. I've printed custom labels for each of the buttons. I've tried to ensure that there's a consistent graphic language for each of these buttons. So on each button on the bottom left in black of the label there is the normal function of the button, and on the top right of the button in blue is the shifted function. Whether or not the calculator is shifted is displayed on the LCD using this upwards arrow symbol, one of a number of custom symbols that I implemented for the device. The calculator implements 6 different operators: addition, subtraction, multiplication, division, raising to a power, and timesing by 10 to the power of. With all of these operators, the calculator is capable of doing decimal arithmetic. These operators can be chained into more complex expressions, which obey the correct order of operations. So here 2 times 2 will be evaluated before 5 plus 2, and the answer will be 9 as opposed to 14. There's a whole hierarchy of operator precedence here. So plus and minus lose precedence to multiplication and division, lose precedence to raising to powers. So for example, if I do the 5 times 2 will be evaluated after the 2 to the power of 2. These expressions generate a running total, and so they can be repeated by the user effectively infinitely. And the sub-expression, which should be evaluated first, is evaluated first. In addition to all this, the calculator has a number of constants. It has pi, Euler's number, and a user-backed programmable constant m. The constants can be used in expressions like any other number. And can also be prefixed with an integer to concisely represent some multiple of that constant. The user programmable constant can be set in a couple of ways. So it can either be directly set using the m equals function. For example, to set the value, the user constant to 1, you would do 1 m equals, and the value now stored is 1. And running totals can also be calculated using the m plus function, which is useful when doing accountancy style arithmetic. For example, to add 4 to the value currently stored in the user constant, 4 m plus, and the value now stored should be 5. The user constant is stored in the TM4C123 EEPROM memory, and so is persistent across power cycles. If I turn the device off and back on, you can see that the value still held in the user constant is 5. Thanks for watching.